Welcome to ECT 2, Local Seminar 3 for Computing. Just a reminder of well-being and safety, apologies. We've got a DSL on the slide if you do need any support from them. And another reminder about the NIOT Wellbeing app as well. Okay, so we're going to have a little look at our learning intentions for today. So to consolidate knowledge and understanding that's been developed through your self-study materials from Module 3. We're also going to be considering how the research underpinning the content can actually be applied in practice. And then you're not going to be able to share and discuss, unfortunately, but feel free to email me some of your thoughts, and I'm happy to discuss that with you. Okay, so we are going to be looking at these 4 things today. So developing pupils' expertise, how we address misconceptions and some of the research around that, teaching critical thinking, and then lastly, just a reminder of your personal professional development. Okay, so we are going to be starting with developing pupil expertise and looking at some of the research from your self-study materials. So I'm just going to give you a second to pause this video and have a go at the retrieval task. Okay, hopefully you were able to do that. So as you can see here, we have got 3 different terms: rote knowledge, inflexible knowledge, and then flexible knowledge. So let's have a look at our answers. And we can see rote knowledge is facts that are memorized without any real meaning to it. So we're just getting students to memorize definitions. For example, we've got inflexible knowledge there, which we are only able to apply to learning within the context. And then we've got flexible knowledge, which is deep structure of concepts, and we're able to apply that to new situations. And it's important to note that both inflexible knowledge and flexible knowledge have its place within learning. Often we are starting with inflexible knowledge. That is often how we're teaching students through definition, through connecting it to one specific example before we move on to that being flexible. So looking at this in a little bit more detail, we know that Willingham has a piece and research around inflexible knowledge and it being the first step to expertise. So in a second, I'm going to ask you to pause the video and reflect on the questions that are going to come up on the screen. So firstly, how has the content that you've read developed your understanding on the different types of knowledge, and in particular, the importance of having flexible knowledge? How has the content deepened your understanding of the different ways that teaching can be sequenced to develop expertise? And then lastly, are there any insights from the content that you wish to explore or develop within your own practice? So pause the video here and reflect on that. I am also going to give you some of my thoughts as well, but please feel free to email me at any point and let me know what you thought about some of these questions. So for the first one, in thinking about how the content has developed your own understanding, I think William's work definitely throughout my teaching practice has helped me understand that inflexible knowledge itself isn't a problem or some kind of failure within your teaching, but actually it is a starting point for students becoming experts within your subject or experts of that topic. So inflexible knowledge is usually tied to specific examples, as I mentioned some slides ago, And that's really crucial for students to learn before they are able to generalize it or they're able to apply it to a broader context. And we're going to look at an example of that in the next slide. And then for that second question, so how has it deepened your understanding of ways that teaching can be sequenced in order to develop expertise? Willingham talks a lot about expertise being developed within stages. So often we are teaching that concrete knowledge first, and then we're able to lead students through using that guided instruction. And then once we know that students have got the basics, we're then able to provide a variation of different problems for them to apply it to. And we do this so much when we're thinking about programming, for example. We've got that step by step and we're guiding them through before we kind of allow them to do any if statement question, for example. Okay, so what does this actually look like in practice? Or what could it look like? So if we consider something basic like an input function that students learn often from year 7 with Scratch or year 8 in Python, when they first learn the function, they learn to use it in an inflexible and a narrow context. So usually we're asking the student to ask for someone's name or ask for someone's age, so forth. But it's important to keep using the function throughout the sequence of lessons. And that means that they start to develop this flexible knowledge of how to use it. So initially I'd be teaching students, usually within the first or second lesson of Python, how to do that input function. But actually, even on the 20th lesson of Python, that input function is still being used, but it might be used slightly differently or taken in different items of data. Okay, so I'm constantly using that, and students start to see that actually this is flexible knowledge and they're able to apply it across to different contexts. Students are given a piece of code with errors and they must debug it. And this is quite a crucial one, and we'll come on to it a little bit further when we look at misconceptions. But being able to identify and to fix issues, so that builds the process of flexible knowledge as well, by getting students to apply their knowledge of programming to different contexts. And then another one, after completing a programming task, students review their code and reflect on their approach. They consider what worked well and what could be improved. And this is really useful, particularly towards the end of the lesson, to do when you are teaching a new concept and getting students to really think critically about code and critique it. Okay, so if we look at that in the form of a question, we've got this typical GCSE question here on the left. This is quite common, often of what we'd expect from a 6th marker. So a student is flipping a coin and keeping track of how many times the coin lands on heads or tails. It says write an algorithm that, and we've got a list of different things that need to be included in that algorithm. So for a student to solve the problem, they need to first have procedural knowledge of all of these different points. So they would need to be able to understand input functions, and by reading the question, understand that it requires an input function. They need to know that it requires a print function, there'll be variables being used here, an if statement, while loops, and then there'll be some process calculations as well. And this is what we often mean by flexible knowledge. In isolation, a student might be able to do a while loop, but actually we want to get to a point for which a student is able to read a question like the one on the left-hand side and know that a while loop is needed and know how to apply it to this question. Okay, so we are now going to have a look at addressing misconceptions. And again, this is based on some research within your self-study. So we've got a retrieval task here, true or false. So I'm going to get you to pause the video here and have a go at identifying which of the following statements are true in relation to the findings from Rich et al. Okay, we're going to have a look at the answers now. So the responses in bold are the ones that are true. So corrective feedback with explanations helped people to correct more misconceptions when tested for the second time. Providing explanations tended to increase students' acceptance of corrective feedback, and those who were more skeptical, or those who were skeptical of the feedback they received, were likely to, or were less likely, apologies, to correct their misconceptions when retested. So what we know from this research is that students were more accurate on the second knowledge test after receiving corrective feedback than on the first test. However, the students who received corrective feedback with the explanations were much more accurate on that second test. So we know that the corrective feedback with explanations is way more effective than without explanations. So addressing misconceptions, we're just going to look at this in a little bit more detail. And again, we're just going to be thinking about these questions up on the screen and reflecting on them. So I'm going to ask you to pause the video in a second. So we're thinking about how has this content, so from Rich et al., developed your understanding of the use of corrective feedback when addressing misconceptions? How has the content deepened your understanding of the importance of clear explanations when correcting a misconception of a pupil? And are there any insights from this content you wish to explore or develop further within your own practice? So you can pause the video here. And I will also feed back on some of these questions as well with some of my own thoughts throughout my own practice. So the first one, how has it developed my understanding of the use of corrective feedback when addressing misconceptions? So one of the things that I'm quite clear about is that learners have to trust the source of the correction. We know that there's a motivational side to feedback that's really, really important. So where they trust the source of that correction, they are more likely to adapt their work moving forward. And also corrective feedback needs to be explicitly confronting the misconception. And what I mean by that is it's not as effective to just say, oh, the answer's A and not B if a student had previously put B, but specifically, why is it not B? And addressing that misconception quite clearly. Yes, it is plausible that it could be B, but it isn't B because of this. And that can be really helpful for a student. And thinking about that second question as well, so how has it developed my understanding of the importance of clear explanations? So I think Rich et al. Highlights that effective explanations really refute the misconception head on, and similar to what I was saying in the previous question. So it's about understanding that misconceptions often seem plausible to a student, as it does when we have misconceptions about content. So it's examining that, why does it seem plausible, and actually why it's not the case, and what the actual answer is, as opposed to only focusing on what is correct. So we want to highlight why something is incorrect as well. Okay, so again, what could this look like in practice? So students might think that knowing one programming language, for example, makes it easy to switch to any other without adjustments. And we know that that's not the case. We know that programming constructs as a whole are quite similar across programming languages, but there is specific syntax and specific nuances to all languages. Students may not grasp that some algorithms are more efficient than others, and then focus instead on getting a correct result without considering performance. And particularly as students get to A level, this is an area that we want to focus on quite a lot. And the last one there, students might equate coding with all aspects of computing, focusing solely on writing code without understanding broader computing concepts like data structures, networks, or cybersecurity. So another question form of how this could look in practice. So these are examples of mistakes that commonly occur when students begin programming. So pupils often need to experience the mistake in order for this to be addressed through modeling or reteaching. But it could be that a teacher actually deliberately introduces those misconceptions, knowing that the result won't be anticipated, and therefore you're going to get into a discussion about why that error has happened. And often when I'm teaching programming, I'll do some live programming with students, and we can make mistakes because we know those mistakes are going to come up, and then ask students about why that was wrong, what am I going to do to fix it, and so forth. So these are three common ones on the board. So using one equal sign instead of two equal signs. Again, when students initially start coding, assignment operators can often be confused with comparison operators. So one equal sign being an assignment, two being a comparison. And that second one, so the top right, not understanding left-hand assignment, which is really common as well. So not understanding that our variable name or a constant name should be prior to the data. And then the last one down there, it being a data type issue, and we we know that we come across this fairly often around input functions. So the student there has missed out the int in front of the input, so not understanding casting needs to be done prior to the if statement. Okay, our third one is looking at teaching for critical thinking. Okay, so again, we have got a retrieval task on the screen. So I'm going to ask you to pause the video in a second to match the description to the steps and then place those steps in correct order. So you can pause the video now. Okay, so this is our correct order and our correct definition as well. So our first one there is identify critical thinking skills. And we can see our definition on the right hand side. So define and explicitly teach specific critical thinking skills relevant to each discipline. And not only are these specific to subjects, but they can also be specific to topics. So the critical thinking skills that I'm teaching within programming are going to differ to the critical thinking skills that I'm going to teach when we're looking at ethics, for example. Determine essential domain content, and we can see our definition there. So identify the subject domain content that pupils need to develop critical thinking skills. Sequence learning, so plan a sequence of skills and knowledge to build on prior learning. And then lastly, ensure long-term retention. So revisit key skills over multiple years to keep revisiting that learning. So teaching for critical thinking, again, we are going to be reflecting on some questions based on the research. So we are firstly going to be thinking about how has this content, so the content from Willingham regarding critical thinking, How has this helped you to understand what critical thinking is and the benefit it can bring to your practice? And then thinking about how do you currently work with your pupils to develop their ability to think critically within specific subject domains? And lastly, what actions will you take arising from this content, and what impact do you expect to see with your pupils? So I'm going to get you to pause the video here and think about the questions on the screen. Lovely. I am also going to reflect on some of these questions as well, just to get you thinking about that. So for the first one, how has this content helped you to understand what critical thinking is and the benefit it can bring to practice? So critical thinking, we know, is not a generic skill. And that's one of the things that Willingham focuses on. Often there's a misconception that critical thinking is somehow innate, and it isn't really, particularly when we're thinking about it within our subject. So one of Willingham's key messages is that critical thinking doesn't exist as this single transferable skill that we can just teach in isolation. So instead, it's about having well-organized knowledge, and he emphasizes that pupils think critically when they can connect new information with what they already know. Okay, so there's that strong foundation of knowledge, and then making that connection there alongside the skill of critical thinking that we are teaching. And that second question, so how do you currently work with your pupils to develop their ability to think critically? So one of the things that I often do is model my thinking out loud, and that was a skill that I maybe learned within my first few years of teaching. That actually students need to hear the expert think. Particularly when we're thinking about things like programming, why is it that I am choosing a particular algorithmic approach, particularly when we're thinking about A-level? Well, I'm able to model that. Okay, why am I choosing to create the variable names that I have, even at sort of Key Stage 3? I'm able to model that thought process, and that helps students quite significantly. But also building a secure domain knowledge first. We need students to know the key vocab. We need them to know all of our key information before being able to think critically about it. And they can't think critically about a topic that they don't know much about. So we want to make sure that those foundations are there to actually best support them with critical thinking within that. Okay, so what does this look like in practice? So it could be things like tasks involving data analysis. We know that students often need to interpret data, and then they need to be able to draw conclusions from that data. So critical thinking is required to ensure that their inferences are valid and that they are also based on sound reasoning as well. So one of the examples that I can think of is at A level, usually within our essay questions, if they're asked to compare two things, for example, they need to be able to think critically about both of those things and draw a sound conclusion. And that's the same at GCSE. So it might be asking them to compare two CPU specs, and often it will have the amount of cache, it will have the clock speed, so forth. So using their knowledge to be able to draw an inference from that and compare. It might be the second bullet point here. So when students design their own algorithms, they must think critically about how to structure their solution, and they need to consider efficiency, scalability, and accuracy as well. And the last point, so when students are tasked with solving a programming problem, they might consider multiple approaches. So critical thinking here would involve weighing up the pros and cons of each method and then choosing the most appropriate one based on the specific problem context. And another example that I can think of pertaining to this is whether a student uses iteration or recursion, for example, to solve a particular problem. So being able to think about the similarities between the two, but also the differences. What does that mean in terms of efficiency, for example? So if we look at some questions around this, so we can see we've got a Python programming question and we are looking at constructing multiple if statements here. So within our program, we have got an input function on that first line, asking to enter the color of the traffic light. We've then got if and we've got elif as well. Okay, so we've got our variable color that stores the color's values and then our three conditions. So I might show a student this in its basic form. I could then show them an alternative to this. So this is doing the exact same thing, but you'll notice here that on line 2, line 4, and line 6, this looks slightly different because I'm now using a Boolean operator within those lines, so my OR, and I'm checking, for example, on line 2, red with a capital R and red with a lowercase r. So one of the things that you often want to be introducing to students once you've shown them what those Boolean operators are is the ability to do something like this. So what would be the benefit of me doing this? What might be a drawback? And often students will say, well, actually, someone might use an uppercase or they might use a lowercase at the start of red. So actually, this might be a better version. Okay, and I'm just going to go back slightly. I cannot do that. So one of the things that you might want to do as well after those two is once you've taught them a bit of string manipulation, then showing it to them with dot lower, for example, and seeing the impact of that. So I am going to give you some to try as well. So use Python to code the following problems below. And once you have your problem working, you can copy and paste this into your own area or write out the program. And these are all programs that can be solved in more than one way. So I'm just going to give you a few minutes to do that and you can pause the video here. Okay, so these are some of the answers on the screen. As I said, you could have approached this in more than one way. And what is really useful about these questions here is that you can see the way that the lesson would be structured to gradually build up the complexity of the task. And it allows students to be able to deepen their understanding at each of these steps. And it also allows them to exercise a little bit of flair within programming, which is what we want them to do. So we've got our first answer on the screen. We've got our second answer. And then our last one there. And hopefully you can see that. So as I said, this is a way in which we can ensure that we are gradually building that complexity when we're looking at something like if statements. We know that in its simple form, if statements can only be a few lines, but actually we can then build that up into a task that requires them to do a lot more. Lovely. So for our last bit, we are looking at personal professional development. Okay, and just a reminder of the professional development model that is used at the NIOT, and you'll be familiar with this model anyway from last time. And in a second, I'm going to ask you to pause the video and have a go at preparing this elevator pitch. Obviously, you won't have time to discuss this with a partner or discuss this within a group, but actually, this is something that you can take back to your mentor and discuss. So, you are going to be thinking about and considering the following bullet points. So, explore aspects of your teaching practice related to subject and curriculum for development. Identify specific aligned strategies or approaches in order to implement it. Plan the execution of these strategies within your unique context, so your school. Monitor the impact of what you do and adjust as necessary. And then lastly, review and reflect on the experience to inform future adjustments and refinements to your teaching practice. So take some time out here to pause the video and reflect on the below. Okay, so hopefully you had the chance to do that and reflect on it. Please feel free to send over your elevator pitches because I'd love to see them, and I'm happy to give you feedback, but also talk to your mentors about it. Remember, this is a great time to really hone in on your practice and developing that and making it as strong as you'd want it to be before moving into next year. So thank you so much for listening today. Please feel free to share your feedback using the QR code on the screen. And I'll just allow you to pause the video here if you need to. So lastly, just looking at our moving forward. Moving on to our next steps, please continue your fortnightly meetings with your mentor to monitor and review your progress and also celebrate your progress towards your personal professional development focus that you've identified. Also reflect and record the progress towards your personal professional development focus by completing the plan to help you actually reach each of those milestones. Apologies. And that also makes it much easier for you to communicate what you've done to your mentor as well. Complete the self-study content for Module 4 before your next live session in Spring 2. And also add the following dates to your diary. So you've got your national expert webinar on March the 4th, and that'll take place online. And then you've got your ECT2 seminar 4, and that takes place on March the 18th. Just want to thank you so much for listening and for your concentration during this session. And as I've said previously throughout the video, I'm more than happy to hear some of your thoughts on the session or some of the research that you've looked at throughout your self-study, or if you've got any questions on how to apply the research within your classroom, particularly within the context of computer science and how that might differ between key stages. And I'm happy to help. But have a lovely day.